Thank you for the chance. I am Dewa Cipta Santosa from Bali State Polytechnics. Is going to present our paper with title Analysis Performance of Full Direct Current or DC Refrigeration Medium Temperature. Our main themes Bapak Mr. Suto Wesnama and Bapak Wijaya Sumo. Production. Indonesia has abundant solar energy, and this energy is one of the reasonable clean energy to be applied. Solar energy sources are very eligible for the operation of the refrigeration system. The conventional refrigeration system with solar energy is still constrained by the relatively high energy losses in inverter, while the innovations that have been made to overcome this circumstance and at the same time to improve the performance of the refrigeration system by developing a system based on full direct current or DC system. Thus, the study aims to obtain the optimum performance of the medium temperature refrigeration DC system with solar energy sources using batteries directly without an inverter. Our research method, our research is an experimental research. Please look at our schematic diagram of experimental setup. Experimental rigs divided into three main components. The first of all is photovoltaic array, then control panel and batteries, and the main component is DC refrigeration system. Refrigeration system is arranged with 6 points to be measured in temperature and pressure as well. 1, 2, 3, 4, 5, and 6. The appearance of this refrigeration system is we use coil extension after evaporator before compressor. This coil is to cool the natural humidifier. This component will be discussed later on in different paper. And also to ensure the temperature superheat of refrigerant before entering the compressor. Okay, for more clear, we saw the photograph of our experimental test rig. The first is photovoltaic array with series and parallel connection. And the second absolutely is the DC refrigeration medium temperature test rig, completely by measurements, instrumentation to measure temperature and pressure mainly. We can see the results of data acquisition and analysis from the figures. can see the temperature condition in each stage point from point 1 to point 6. This is refer to refrigeration schematic diagram which saw previously. On this figure can be seen that compressor works very optimally according to the on and off control setting condition. Up and down of this graph is indicated on and off of the compressor. This is normally operational refrigeration. Okay, continue. Results. This is the temperature condition in cabin and product. Well, product is press vegetable. So can be seen that the temperature difference between near evaporator position and near door position is slightly high at around 3 degrees C. And also temperature difference between upside and downside cabin 6 degrees C. This problem can be solved with better insulation of the cabin. Continue our result and discussion. Based on the data acquisition, we can calculate the average value. State it point, temperature 1 to temperature 6, pressure heights, pressure low, relative humidity, temperature superheat, and temperature sub. So from the table, can see that condition of degree of superheat is quite high if compared with empirical normal condition around 3K until 13K. We found that 19K. This is because of cooling load in cabin also high. In terms of degree of subcool, it is slightly high as well. General standard 2K until 5K. We found around 7K. This is because the installed condenser capacity is slightly larger, higher than required capacity. Considering the availability in the market for fin and tube type condenser. Meanwhile, from the table data we can calculate the COP or coefficient of the performance of the refrigeration system as whole we found around 3.63. This is quite good COP of refrigeration system. Conclusion is on the above result and discussion. It can be concluded that the refrigerator system with total direct current or DC has good performance, which indicated by the COP is 3.3. If average conventional refrigeration in medium temperature COPs is around 2.5 until 3. This COP can be considerable very good if compared with the conventional refrigeration system. However, to improve the optimization of the system, it needs to be done with better insulation on cabin. This is indicated by the temperature difference between up and down part in the cabin is slightly high at around 6 degrees C. Okay, Thank you very much for your attention.